Here are the background about ATX SMPS or switch mode power supply. Switch mode power supply has three categories. First is what is ATX SMPS, second is how SMPS configure, and number 3 is advantage of SMPS. So what is ATX SMPS? AT and ATX stands for Advanced Technology Power Supply and Advanced Technology Extended Power Supply. Both are types of switch mode power supply. SMPS is an electronic power supply system that makes use of switching regulator to transfer electrical power effectively. Number 2, how SMPS configure. The three main topologies used in switching power supply are back, also known as forward, boost, and back boost, alternatively called flyback. All of them utilize the same three elements: transistor, inductor, and diode, but they are arranged in unique ways. And lastly, the advantage of SMPS. First is compactness. Being able to shrink the supply is essential for the many modern electronic devices that lack space. Number 2 is high efficiency. Most switch and power supply have efficiency levels of between 80% to 95%. Number 3 is flexible applications. Extra windings can be added to a switching power supply to provide a multiple output voltages. Here is the example of switch mode power supply ATX.
Let's now proceed to the common components found in SMPS. First one is AC input, used to connect SMPS to AC. Input filter consists of capacitors and conductors. Rectifier converts AC to DC. PFC improves the power factor. Main capacitor stores energy. DC to DC converter, it is the heart of the SMPS, consisting of switching transistor, driver circuit, output inductor, and output capacitor. Feedback control circuit, it's a control circuit senses the output voltage and adjusts the duty cycle of the switching transistor. Output filter consists of capacitors and inductors. Output voltage sensing circuit senses the output voltage and provides feedback. Overcurrent protection protects the SMPS from overloading and short circuit by shutting down the output. Thermal protection protects the SMPS from overheating by shutting down the output. Fan, it is used to cool the SMPS and preventing overheating. Auxiliary power connectors used to provide additional power. Standby power circuit provides power to the motherboard even if computer turned off. EMI filter, it consists of capacitors, inductors, and resistors that reduce electromagnetic interference generated by the SMPS.
I discussed the design and construction of switch mode power supply. Step 1. A good specification. A proper specification is the core of everything. It's essential to take the time to thoroughly research your requirements and produce a specification. So this is the different model of SMPS. Step 2. A first decision. Linear supplies offer advantages such as easy of design, low cost, useful components, tried and true methods, and little EMI emission. So we need to make a decision for making a SMPS. Step 3. Expanded specification. In addition to the basic specification compiled earlier, this should also be defined for your design. Requirement for electrical isolation between input and output. Temperature range of operation. Expected inrush current, peak and average output current. Transient exposure and response needs. Load and line regulation requirements, switching frequency. Step 4. Choose a topology. The most popular DC to DC SMPS topologies are back, boost, inverting, back boost, ZF, and Zeta. The MOSFET does the switching, the inductors and capacitors stores energy, and the diode controls the direction of current. Step 5. Begin your design. Low frequency are prepared for higher power application, while higher frequency facilitate filtering with smaller capacitor and inductor. Ditching can reduce switching EMI by splitting the spectrum over a wider range. Step 6. Other sources, integrated circuits, and diodes are the core of a design, with reference designs and valuation kits available.
Today I will be discussing to you the PCB layout of an ATX power supply. The 220 volt AC main voltage is located on the left side and is first rectified by a complete bridge rectifier. And then, a DC voltage is produced by smoothing it out with capacitor. And then, a type of transistor quickly turns on and off this DC voltage, creating a PWM signal are produced at a high frequency. And then, the main side of a transformer is connected to the high voltage, high frequency PWM, which causes the secondary side to experience a low voltage, high frequency PWM voltage. Last but not the least, capacitor are used to smooth out this voltage once again in order to get the desired DC voltage. The A part here is the bridge rectifier. The B is the input filter capacitor. Between the B and C, there is a heatsink. And then the C is the transformer. Between the C and D, there's also a heatsink. The D is the output filter coil. And then the E part is the output filter capacitor. On the back part of this ATX power supply, you can see the PCB layout looking like this.
SMPS application and voltage output. Voltage output. Most switch mode power supply or SMPS for desktop PCs are AC to DC. That means SMPS takes AC mains input and outputs DC that range to 3.3 volts to 12 volts. Input is 110 to 230 VAC, output DC is 12 volts without a fan. The alternate switching mode power supply or SMPS, which converts an input voltage of 85 to 264 VAC to 5, 12, or 24 DC, provides power to field transmitter as well as other instruments. Application of SMPS. It's powering on of your personal computer, charging your battery cars, used for factories and industry for powers, used for railway and security system, and for lightning system. Thank you for listening.